I was going over the solving linear equations, and I got kind of confused on how to graph a linear equation in standard form.
Okay. Graphing linear equations in standard form?
Yeah.
Okay. That right there is standard form. AX plus BY equals C.
Okay. So would that make
Right.
B? Would that be y-intercept or? Is it
Well,
different?
let's graph some. It's real easy, actually. In fact, the easiest graphs to graph are in standard format. Let's take 3x plus 2y equals 12. Notice that that's standard format.
Okay.
And the reason it's so easy to graph is all you need is the x-intercept and the y-intercept, and you have 2 points, and that's all you need to graph a line. So how would I get the y-intercept?
Well, there's no b in the equation, so.
Well, the y-intercept means what about x? What is the x value when we are crossing the y-axis?
X equals 0.
Okay, so plug in x equals 0 and solve that for y.
What was that?
Plug in x equals 0 and then solve the equation for y.
Would it be y equals 6? Wait!
Yeah.
I think.
In other words, this point has to be on that curve because that point is 0, 6. Now how about the x-intercept? What is true about y when we're trying to figure out the x-intercept?
Y equals 0.
So plug in 0 for y and solve for x.
Okay. So that'd be x equals 4. Sorry, yeah, 4, 0.
Okay, so those 2 points are on the graph, and that's all you need to determine the equation of a graph. Notice we never had to solve for slope. That's the one time you don't have to worry about slope, is when you're graphing an equation that is in standard format. And this is pretty easy to do. In other words, figuring out the x and the y-intercepts from standard format is real easy because you just plug in 0 for the other one. So let's have you do a few here. Graph number 8, or tell me how to graph it.
So
I'll write it. I'll rewrite it. Minus 18x plus 9y equals 72. Again, it's in standard format.
well, the first thing I would do actually is just to simplify the equation, divide everything by 9. Using
Okay.
the division
Good.
equality.
No, I like that. I like that. So what do you got?
Negative 2x plus y equals 8.
Okay.
Okay, so then you would put a point at 1 minute. 8 comma, wait, no, sorry, y 0, comma 8.
Okay.
And then another one at negative 4, comma 0.
Okay. Just connect the two dots, and there's your line. Yeah. Notice that even if you didn't notice that thing, you would have still got the exact same 2 points. In other words, if I plug in 0 for x, y is 8. In other words, I still get that same point, even though I don't divide everything by 9. And then if I plug in 0 for y, I still get minus 4 for x. So the question is it worth doing that step? Because I'm not sure that it solved anything. In other words, if I work directly from this function, I get the same 2 points in basically 2 steps. So taking a step to simplify that ended up being not really worthwhile. Not that I have any problem with you doing it. It's wonderful that you immediately spotted the fact that 9 is a greatest common factor, or minus 9. 9. But it is also worthwhile noting that if we're going to solve it by x and y intercepts, then we don't really need to do that. Let's look at this one here. So just give me my x and my y intercepts. Don't even need to give them to me as a coordinate point.
So the y-intercept would be, would that be negative 0, comma negative 2?
Just the y-intercept.
Well, that would be the y-intercept, right?
Right, but it's not negative 2. Plug in 0 for x and solve the equation for y.
Oh, negative 1/2, sorry.
Right. Okay, so this point right there at negative 1/2, that's on our curve. How about the x-intercept?
1/8.
Positive what?
1/8.
Okay. Right, about there. More difficult to draw a line through, but nonetheless.
Okay.
10 is a little different because it has fractions. Now, notice on this one that you could simplify this one also if you chose to. How would you simplify this?
Multiply everything by 4.
Yeah, and then that gives you x plus 3y equals 4. But again, that's not going to be of any value. Let's graph it based on either one of these equations. Give me the x-intercept and the y-intercept.
Okay. The x-intercept would be 4,
Okay.
comma 0. And then the y-intercept would be 4/3 or 1 1/3.
Uh-huh.
Yeah.
And again, you get those same numbers even if you don't simplify that equation.
Oh, sorry, that's 1 second. Yes?
Yeah, it's a little harder to come up with just because you have to deal in fractions. In other words, when you're trying, if you start with the original equation, you have to solve this, which means multiplying both sides by 4. So you still come up with the x-intercept of 4. It's a little easier to come up with that from that equation. So in this case, I don't know. It's just preference. Whether you prefer working with equations like this or equations like that. If these don't give you any problems at all, then it's actually more direct to work with the original ones. But let's see what else this page has here. Can you read this page good enough? I'm trying to figure out. Can I?
Yeah, I can.
Not sure I have the ability to blow it up. Oh, yes, I do. What am I even thinking here? Here, I can. There. Okay, so write number 5 in slope-intercept form.
Okay. Number 5.
I'm sorry. Yeah, number 5. Yeah.
Y equals negative 2x plus 17.
Okay. How about number 6?
Y equals 5x minus 1/4.
Good. Did you move the y to the right? Is that how you did it? Or did you move everything else to the right and then divide everything by minus 1?
Yeah, that's what I did.
Either way. Okay. I know you know how to do 7. Number 11, what's the x-intercept?
Negative 6 comma 0.
And the y-intercept?
0 comma 3.
Okay, so I know you know how to do 11, 12, and 13. What is the y-intercept? What's the x-intercept on 13?
There is none.
Okay. (16, 17, and 18 are very similar to what we just did.
Yeah. So should we do those or?
Well, you know how to do all of these.
Yeah.
Fine.
If you go to their, oh.
Go ahead. Do what?
I actually forgot. Sorry.
Here,
Never.
yeah, I can scroll down here a little bit. Let's see. We just did a bunch like that. I know you know how to do those. How about some of these word problems?
So.
In other words, 19 is no big deal. 19 is the same as 16, 17, and 18. Let's look at 20.
Okay. So, if gear is $50 a day,
Right.
boat,
And the boat's $250.
so it'd be 250x plus 50y equals 1,000, right?
Correct. Good. To graph that, well, let's go ahead and graph that because they want us to interpret the graph. So what are my x and y intercepts? What was the equation? It was 250x plus 50y equals 1,000.
Yeah.
It's the x-intercept?
the x-intercept will, yeah, 4.
Okay. And what's the y-intercept?
Y-intercept would equal 20.
Okay. Now, what's the meaning of those two intercepts?
For the, oh, sorry,
But that's okay. Let's see. This is the x-axis. This
yeah.
is the y-axis.
Yeah, so I think you've learned about this. So, for the x-intercept, it's, if you rent gear, oh, sorry. Yeah, if you rent gear for, wait.
Yeah, this is a little strange.
Oh, yeah,
Because
no.
there's actually 3 things. In other words,
Yeah.
trying to graph something in 2 dimensions, x and y, but it's doesn't take into the account time.
Yeah.
In
Okay, so,
other words, we know that when x is 0, that's the y-intercept, right?
yeah.
But the y-intercept merely means that if, in other words, y is 0 also. You think about this for a moment.
So, for the x-intercept, you can rent the boat for 4 days if you rent the gear for 0 days.
There you go. And if you rent the boat for 0 days, you could rent the scuba gear for how long?
For 20 days.
Exactly. Good. That's the perfect way to put it. Because this x-axis is not time.
Yeah.
That's why it's a little confusing, this problem, is because a lot of times in an equation like this, you'll want to know what the total cost would be for X amount of days. And so the horizontal axis would be the amount of days, and the vertical axis would be the total cost. And that would be the total cost would equal 250x plus 50x. Well, plus 50y. If x and y are the same thing, then that would be your total cost. Interesting. Okay.
Five friends go scuba diving. They rent a boat for X days and scuba gear for Y days.
How do I
The
turn
total
that off?
spent is $1,000.
You can't until it's done saying the equation. Yeah.
That's kind of weird.
If you click on it, it starts playing.
Oh, I must have accidentally clicked on it. I thought I just passed the cursor over it, but all right. So let's look at 21.
Okay. You work at a restaurant and host as a host and a server. You earn $9.45 for each hour you work as a host and $7.65 each hour you work as a server. Write an equation in standard form that models your earnings.
Okay.
Okay.
The
So
first step of this would be to do this back information, basic information rather.
okay.
In other words, if they didn't have this page right here, then the very first step would be to make up your variables and label what they are.
Yeah.
Well, you would say that X is the number of hours you work as a host, and Y would be the number of hours you work as a server. So what's your total earnings going to be?
$160.65.
Okay, so what's the equation?
So 9.45x plus 7.65y equals 160.65.
Yeah. Or equals your total pay. In other words, if they hadn't told us that the total pay was 160, then this would have been a variable that depends on x and y. Notice that we're no longer talking linear if we're talking that. In other words, for something to be a linear equation, it's got to have an x and a y precisely. If all of a sudden I enter a z here, which is your total earnings, then it's no longer a linear equation. So let's not go there yet. I'm talking about that, in other words. And then you can graph this just like we've been graphing all of them. Graph the x-intercept and the y-intercept. And at least on this one they don't ask you to interpret it, which is good because I don't really like having to interpret that because the interpretation of it doesn't mean a whole lot.
Okay.
Does the graph of every linear equation have an x-intercept?
What?
Number 22, does the graph of every linear equation have an x-intercept?
Yes.
How about this one?
Oh, no. Wait.
That's actually a linear equation. What this is y equal a slope of 0 times x plus 2. In other words, this is actually in slope-intercept format. It's just that the slope is 0, taking this term out of play. And that since that's a horizontal line, it never touches the x-axis.
Okay.
So the answer is no. And likewise, not every linear function has a y-intercept. That is a vertical line.
Okay.
Okay? So actually I was wrong earlier when I said every linear function has an x and a y. Those are two examples of where they don't. We got probably just enough time to look at 23.
Okay.
A veterinarian charges $70 plus 40 bucks an hour. Write an equation that represents his total fee charged by the, so y is going to be the total fee. But that's okay. We still have a linear equation. What's y going to equal?
So
X is the length of the visit in hours.
okay. So it'd be y equals 40x plus 70.
Uh-huh. Now, if I graph that, I don't have to do x and y intercepts because it's in slope-intercept format. So I know the y-intercept's at 70. The slope is 40, which means I'm going to go up 40 and over 1. So there's my curve, let's say. What does the y-intercept indicate? Let's see, what do they ask here? Find the x-intercept. Will this point appear on the graph of the equation and explain your reasoning?
Okay, so when you originally go to the vet, there is an original cost of $70 before anything happened.
Okay, so their question says is, will the x-intercept appear on the curve, on the chart?
What was that?
The question says, will the x-intercept, find the x-intercept, will this point appear on the graph of this equation, and explain your reason.
Okay.
I mean, it looks like it does. I've graphed it.
Well, it wouldn't really be logical, though, because...
Exactly, because time is never negative.
Yeah,
So,
unless you have, like, a time machine.
Yeah, let's not go there. But for all practical purposes in math, time is never negative, dimensions are never negative. So whenever you come up with negative things for either one, you throw them out. In fact, this curve starts right there.
Okay.
Okay? And the y-intercept means what the charge would be if the vet didn't stay even a minute. In other words, if the vet got there and left so that the amount of time was 0 hours, he would charge you $70 for showing up.
All right.
Actually, that's a good question. You know what? I'll bet you, based on this problem, that should be an open circle right there.
Yeah.
Not a closed circle. Because if he didn't work at all, I don't know that he would charge you $70. He might have to put in at least a minute to charge you that 70. But I don't know. That's strictly hypothetical there. And graph the equation, which we did.
It's like someone rushing into the ER and saying, hey, before we do surgery on you, you're going to have to pay us a few $100s.
That's a good example. It's not quite accurate because if they did that, they would be getting an advance. In other words, they would say the $200 you give us will count against the charge that your surgery is going to be. In other words, if your surgery, the charge was $300, you would have merely paid the $200 in advance. It's not quite the same as a show-up fee. It would be more like the hospital says, we're going to charge you $80 to walk in the front door. And then we're going to charge you for whatever procedures you have. And that way, there's a fixed cost that even if you have no procedures and don't spend any time, you're still going to pay that $80 to walk in the front door.
Oh.
And that's kind of what the vet is doing.
A way you could think of it is if it's kind of like the admission fee at a carnival. You have to pay to get in, but you also have to pay for every other ride.
There you go. That's exactly what it is.
Okay.
Just like that. It's a fixed cost that's not really dependent on how much other stuff you do.
Awesome.
Okay, cool. David, I will talk to you next Tuesday.
Oh wow, that went by fast.
Enjoy your skiing if you get a chance to go over the next week.
Maybe Copper Mountain, or because usually when snow falls there, it's really powdery.
Yep.
And not a lot of people are there, so the chairlift lines aren't that long.
I've skied Copper Mountain many, many times. Not for a long time, but many, many times when I was skiing, I skied Copper Mountain. It was one of my favorites. Copper Mountain, Loveland, Keystone, those are all my places I'd go.
Usually I go to Winter Park or Breckenridge, which are always really crowded.
Yes.
Yeah, but we do have friends that live up there. So.
Yeah, my sister lives up near Winter Park. She lives right outside of Grand Lake.
Okay, cool.
All right. I will talk to you next week.
Okay. Thank you.
Bye-bye.